Hello, grade 7. Today we are going to complete the second part of lesson 1, which talks mainly about the structure of the atom. Starting with the something called isotopes. What is the meaning of isotopes in grade 7? We said that any atom has mass number and also has an atomic number, right? But the isotopes here means that we have many different forms of the same element have the same atomic number but different in the mass number. And because they are different in the mass number, of course, they are different in their number of neutrons. Let's see like what? Like helium and hydrogen also. Sorry, hydrogen has 3 isotopes. Protium, as we see, deuterium, and tritium. If we observe the atomic number, we can find that all of them have the same atomic number, which is 1. But they have different mass number, 1 in protium, 2 in deuterium, and the tritium has 3 in their mass number. So again, isotopes means different forms of the same element, which is here hydrogen, have the same atomic number, which is 1, and different mass number, which is 1 here, 2 in deuterium, 3 in tritium. Also the magnesium has isotopes, 3 isotopes, have the same atomic number, which is 12, but the first one, its mass number is 24, the second one 25, the third one 26. So if I want to extract any 2 isotopes for the same element, the first step I have to search about the same atomic number. They have similar atomic number. The second part of the lesson talks about something called energy level. Do you remember when we said in the previous session that any atom consists of 2 main parts, right? Excellent. Nucleus and electrons that revolve around the nucleus. And the electrons here revolve around the nucleus in energy levels in certain places, and these places are called energy levels. And the number of the energy levels in the heaviest atom is 7. Their symbols are K, L, M, N, O, P, and Q. And as we see, you have to write these symbols in a capital letter. Okay, and each main energy level has energy sublevels. But now we have a rule. This rule is 2n power 2. And the 2n power 2, I can use it to calculate the number of electrons in the first 4 energy level, which means that till the level n. As n here in the rule represent the number of level. So if I want to calculate or to know the number of electrons that saturates the K level, I will apply this rule 2n power 2, and the n here represent the number of level. And because the K is the first level, so I will write 2 times 1 power 2 equals 2 electrons. So K saturated with 2 electrons. What about the L? Also, L is the second level. So 2 times 2. Why I wrote times 2? Because 2 here represents the number of the level, and the K is the second level. So I will write 2 times 2 power 2, which is equal 8 electrons. So L level saturated with 8 electrons. What about the third one? M. And the M is the third level. So third means 3. So I will write 2 times 3 power 2 equals 18 electrons. While the fourth energy level, which is N2 times 4 power 2 equal 32 electrons. But I cannot apply this rule for more than 4 energy level. So I cannot apply 2 in the power 2 for O, P, and Q because the atom may be unstable. It's not in its ordinary conditions above the 4th energy level. How can we distribute the electrons in the energy level? At first, when I distribute the number of electrons. But I don't have the number of electrons. When I write any element, we say that it has 2 numbers. One of them is the mass number, and the other one is the atomic number. Where are the electrons here? So the atomic number, we said also in the previous session that the atomic number equals the number of protons and also equals the number of electrons. So when I distribute the electrons, I mean the atomic number. Let's see how can we distribute the electrons in the main energy levels. Starting with the hydrogen. How can I write the hydrogen? At first, I have to write that the hydrogen has mass number 1 and atomic number 1. I will distribute which number? I will distribute 1, which is the atomic number, because the atomic number is the number of electrons. At first, I have to draw the nucleus. And inside the nucleus, I have to write the atomic number, which is 1. And don't forget, its charge. The second step, I will draw the energy level. The first energy level that I have is K. And we said that the K can be saturated with 2, can be filled till 2. And here I have 1, so I will write 1. Is it right? Yes, is it right? I have finished? Yes, I have finished. Another element, lithium. Lithium here, its atomic number is 3, so the number of electrons is 3. How can I distribute it? At first, I have to draw the nucleus and write 3 inside it, positive 3, as the protons has a positive charge. Then the second step, as we always do, I have to draw the K level, and the K saturated with 2. Excellent, so I will write 2. But the atomic number here is 3, so the rest will be 1. I will put the 1 in the next level, because the K saturated with 2 and the L can be filled to 8 electrons. And I have 1 only, so I will write 1 in the next level. Okay, another element. I have sodium here, and the sodium has atomic number 11, so the number of electrons also equals 11. At first, I have to draw the nucleus as on the board and write 11 inside the nucleus, positive 11. Then I will draw the K level, and we say the K level saturated was 2. Very good, grade 7, so I will write 2 here. Then the second level, which is L. And the L, grade 7, can be saturated till number 8. And I cannot put more than 8 electrons in this level. So I will write 8 here. So 2 plus 8 equals 10. And I have 11, so the rest will be 1. Can I put 2? 9? No, this will be false, because the L11 cannot be saturated with more than 8 electrons. What should I do at this case? I will write 1 in the next level. I will complete in the M level, which can be saturated with 8 electrons, so never mind to put 1 inside it. This is the right drawing, or the right configuration, or the right distribution for the electrons for the sodium element. Let's take another element, calcium. And the calcium, grade 7, has atomic number 20. As we always do, the first step, I have to draw the nucleus. Then I will write the positive charge and the number of protons, which is 20. Then the second step, I will draw the K level. After that, I will do what? We said that the K is saturated with 2, so I will write 2. Then the L level is saturated with 8, so I will write 8. But let's add 2 plus 8 equals 10, and I have 20, so the rest will be 10. How can I put the 10 in the other levels? Let's see. Also the M can be saturated till 8, and I cannot put more than 8 electrons in the M level, so I will write M. That 2 plus 8 plus 8 equal 18, and I have 20. The rest here will be 2 electrons. Can I put 10 here? No, because the M cannot be filled with more than 8 electrons, so the rest 2 I will complete in the next level, which is N. N can be saturated with 8 electrons, and I need to put only 2 electrons, so I will put 2 here. So this is the right distribution, or the right configuration for the electrons for the calcium elements. Now we have finished how can we learn, or how can we write, or how can we draw the electronic configuration for different elements. Maybe hydrogen need 1 energy level, maybe lithium need 2 energy levels, maybe like the sodium need 3 energy levels, or maybe like the calcium need 4 energy levels. Let's complete grade 7. Okay, let's see. The third part that we will talk about it, the energy level. Don't forget that the energy of the electron increases by increasing the energy of the level. Sorry, as we go further from the nucleus. And the quantum here is very completely different. So the difference between L and M is less than the difference between K and L. And the difference between M and N is less than the difference in the energy or the quantum between L and M. So the energy of the electron increases as we go farther from the nucleus. But the difference between the energy level in quantum decreases as we go far away from the nucleus. There is a big difference between the difference in the quantum over the energy of the electron. The energy of the electron increases as we go away from the nucleus. But the difference as I go away from the nucleus, the difference here decreases. So the difference between K and L is great, then decreases between L and M, then decreases more and more between M and N, and so on till we reach to the Q energy level. Before answering the questions, I want to tell you something very important. May I give you the atomic number of the element, and I want you to draw the energy levels and distribute the electrons in their main energy level. Or I give you the figure and I want you to calculate the atomic number from the figure. Like what? Like, I will draw now an example for you. Like magnesium. Magnesium in grade 7 has 12 protons. Or no, I will not write the 12 protons. I will draw just only the nucleus. Then I will write K, L, M. It has in the first energy level 2, in the second one 8, in the third one 2. What is the atomic number here? The atomic number is the number of electrons, right? So I have to add the number of electrons to calculate the atomic number. 2 plus 8 plus 2 equal 12. So it has 12 atomic number. So the question is in this part may give you the configuration or the drawing like this and wants you to calculate the atomic number, or even the opposite, give you the atomic number and distribute the electrons in their main energy levels. Let's answer some questions in the booklet as we always do. How can we distribute the number of electrons in the energy level? The first example that we have, calcium. And the calcium here has 40 as a mass number and 20 as the atomic number. At first, I have to know what is the number that I have to draw and distribute it, the atomic number, because as we said, excellent, the atomic number equal the number of electrons. So the first step I have to do, draw the nucleus and write the positive protons inside the nucleus. The second step, excellent, here, grade 7, I have to draw the K level, and the K situated with 2 electrons. Very good. What about the L? The L situated with 8. What about the M? The M situated with also 8. Now let's add these numbers. 2 plus 8 plus 8 equal 18. But the atomic number here is 20. So I will complete in the fourth energy level, which is N, and I can put 2 electrons in the N level. I cannot put 10 here. This will be false because the M level can be saturated with 8 electrons, not more than 8. So this is the right configuration, okay? The second example, nitrogen, and the nitrogen here has 7 as its atomic number, which means that the number of electrons here equals 7 also. At first, I have to draw the nucleus as we always do. Then I will write positive 7. This is the number of protons. Then I will draw the K level. And we say the K level can be situated with 2. Excellent, yeah, grade 7. Okay. What about 2? 7 minus 2 equal 5. So the rest will be 5. Can I put 5 in the L level? Yeah. It can be saturated till 8 electrons. And I need only 5 electrons. So I will put the 5 in the second level. This is the right configuration for the nitrogen. Let's take another example. Let's see. Oh, argon. What about the argon? Argon in grade 7 is one of the inert gases or inactive gases that don't participate or even share in the chemical reactions. It's completely filled with electrons in its ordinary conditions. How can I distribute it as I always do? Let's see. First, I have to draw the nucleus. Then I will write the positive protons inside it. Then I will draw the K level and I will put what's in the K level? Excellent, 2 electrons. What about the L level? I will write the L, and the L can be filled with 8, so I will write 8. That 2 plus 8 equal 10, and I have 18, so 18 minus 10 equal 8. The rest here will be 8. And also the M can be filled with 8, so I will write 8. Because it can be filled till 8 electrons. So this is the right distribution for the argon, or for 18 electrons for the argon as inactive gas. Okay, so today in grade 7 we talked about what? We talked about the meaning of the isotopes, the meaning of the energy level and the sub-energy level, and the difference in quantum between the main energy levels, and how can we draw the configuration for the electrons or draw the electronic configuration for different elements, or maybe give you the figure, and from the figure you can conclude the number of electrons by adding the number of electrons here to calculate the atomic number. Just study hard, answer different questions as we always do, and with the best wishes. Goodbye.